Welcome to qnawire.
In this problem on the topic of light waves, we are shown in the figure three equidistant slits being illuminated by a monochromatic parallel beam of light. We are told then that B P naught minus A P naught is the wavelength lambda over 3, where D is greater than lambda. We want to show that in this case, little d is the square root of 2 lambda capital D over 3, and then show that the intensity at P naught is 3 times the intensity due to any 3 of the slits individually. Now, from the figure, we can see that B P naught minus A P naught is equal to lambda over 3. And so this means that the square root of capital D squared plus little d squared minus d is equal to lambda over 3, which means that capital D squared plus little d squared is equal to capital D squared plus lambda squared over 9 plus 2 lambda capital D over 3. And so we can make little d the subject of the formula, and we get this to be the square root of 2 lambda capital D over 3 as required if we drop the lambda squared over 9 term, since it is very small. For part B, we want to find the intensity at P naught, and so we have to consider the interference of the light coming from all 3 of the slits. And so we have Cp naught minus Ap naught to be the square root of capital D squared plus 4 times little d squared, and all of this minus d. And so we can write this as the square root of capital D squared plus 8 lambda capital D over 3 minus capital D, which we can write as d into 1 plus 8 lambda divided by 3 times capital D all to the power half minus d. And so using the binomial expansion, we can write this as d into 1 plus 8 lambda over 3d times 2 plus higher order terms, all of this minus d, and this is then equal to 4 lambda over 3. And so the corresponding phase difference between waves from C and A, phi C, is equal to 2 pi x over lambda, which is 2 pi times 4 lambda over 3 lambda, which is 8 pi by 3, which we can write as 2 pi plus 2 pi by 3. So this phase difference is simply 2 pi by 3. And again, we have phi b, this phase difference, to be 2 pi x over 3 lambda, which is 2 pi over 3. So it can be said that light from B and C are in the same phase, as they have the same phase difference with respect to A. So we have capital R being the square root of 2 times little r all squared plus little r squared plus 2 times 2 little r times little r cosine 2 pi by 3. And so simplifying, we get this to be the square root of 3R. And so the intensity at P naught, I minus K into the square root of 3R all squared is equal to 3 times Kr squared, which is simply 3 times the intensity I as required.